welcome back. This is Angie with Angie's Beyond the Lecture, and this is our final stop in the chemistry final exam review. And this is sort of the foundational review that covers maybe the first 25 to 35 or 30% of the semester. So it's the basics, it's the intro part, it's, semester-wise, it's probably the first month or two of all the topics that you discuss and learn about. Now, our last stop on the train is going to be Intro to Atoms and Isotopes. And really, we're just talking about the subatomic particles, the particles that make up the atoms by definition. We'll talk about those. We'll talk about the two types of notations you'll see. And as I scroll down here in my notes, yeah, because we're already on review problems, right? We'll talk about ions, how those are generated by gaining or losing electrons, and sort of round out this particular topic. Because from here, what happens is that after this particular topic, and whether you're in high school or intro to college chemistry or gen chem, you're largely going to study the same topics, but the depth and the difficulty might vary depending on where you're at. And this is where I sort of have to stop. So again, this series is designed for high school chemistry, college chemistry, general chemistry. You get the idea. But at some point, things are going to get more difficult for general chemistry versus high school chemistry. So at that, we'll go back to this main topic on the concept of the atom. And of course, the atom is sort of the fundamental unit of elements, right? And they have certain characteristics that are unique unto themselves. And largely, that's the number of protons, right? So we have in our nucleus of our atom, we have protons and neutrons. And protons have a +1 charge for each proton. And the number of protons identifies the element. So if I am told, hey, look at your periodic table and tell me what element has 6 protons, you would say carbon. And that will never change. If you have an element that has 6 protons, it's always carbon. And again, the periodic table is your friend, and you should have it on most exams and quizzes. That's something you can go to and tell right away which elements have the number of protons to identify themselves. Now, neutrons have no charge, and they reside in the nucleus. They contribute to the mass of the nucleus and the atom, but they can vary in number, okay? And we'll determine some of this information here as far as how many protons, how many neutrons does an element have based on the periodic table. Electrons. Now, electrons carry a -1 charge, and they occupy the space outside of the nucleus. And in a neutral atom, it's always equal to the number of protons. So that's a nice, easy button way of knowing the number of electrons in a neutral element. Now, this is where chemical reactions take place, chemical bondings and chemical reactions. So in essence, either elements share electrons or they just completely transfer an outer electron that they essentially no longer have control over, and they create ions. And we'll discuss that a little bit here down the road. Now, for isotopes, again, isotopes, they are the same element, so they have the same number of protons, but they are going to have a different number of neutrons, okay? And we can actually look at isotopes using isotopic form and determining, okay, is this a isotope or not? So symbolic notation, we're looking at the very lower left-hand corner of the screen, and it says carbon-13, carbon-13, that's mass notation. Isotopic notation is that C with a 13 over the 6. So I am gonna take my fingers here and zoom in on that. So this is, on the left, we have mass notation, right? Mass notation. And then we have, this is isotopic over here. Okay, and they tell us the same stuff, just different notations. And this carbon-13 tells me it has 13 protons and neutrons total. That's our A. That's protons and neutrons. And then this is just going to be our Z, that's our atomic number, and that's protons only. So all we have to do is simply take these two numbers and subtract to get our neutrons. 13 minus 6 would be 7. We would have 7 neutrons in this particular setup, 6 protons, right? Because this identifies your protons, that lower number. And then if we were to answer the ultimate question of electrons, we would just say 6 as well. So I'm going to sort of reset the screen here, just a moment. We'll back up here. Again, to be clear on this carbon 13, or C13 over 6, we'll have 6 protons, 7 neutrons, and electrons are 6 as well. Notice that these two quantities match, okay? And did I note that down here? No, I didn't, yeah. So what we're saying here from this example is that we have our mass number of 13 on top, our atomic numbers on bottom, that's the number of protons, and C is the elemental symbol for carbon. So you can basically, whenever you're given either the mass notation or the isotopic notation, you can tell all kinds of information. I can tell how many protons I have, how many electrons I have, how many neutrons I have, and that's simply subtracting those two numbers. And to dissect, I think you should be aware of the isotopic notation here, A and Z. Yeah. So if you were to Google, for instance, isotopic notation, you'll probably see this X for the symbol and then A and Z. This is just a generic notation, right? And again, this is mass number. Okay, so when you think of mass, the two subatomic particles that contribute to mass are your protons and neutrons. So it should make sense that, this is the sum of both protons and neutrons, and then this would be just P only. And that's your atomic number. P only, okay. And I realized that for some reason, and I remember being in chemistry and going over these quantities and having a heck of a time understanding mass number is what now and atomic number is what now. Just remember, mass is contributed by the protons and the neutrons in the nucleus. So it's intuitive to understand that you're just simply adding protons and neutrons together. And then your atomic number, the number below, simply symbolizes the number of protons. And then from there, if you take A minus Z here, you'll get number of neutrons, and then electrons always equals protons. As long as it's neutral, right? As long as we don't have a charged, metal or element, okay? And yeah, we have examples of mass notation here. We have carbon, hydrogen, uranium, right? And it's just specific on telling us what isotope we're dealing with. Now, in a general sense, and this will be studied further on in chemistry, we're going to stop right here. Atoms become ions when they gain or lose electrons. So you could see a notation, for instance, I might give you Na plus, okay? And that Na plus, let's see here, Na has 3, I'm doing this off memory. Sodium, all right, so sodium is in group 1, right? And it should have a mass of 23 and then the atomic number of 11, right? So, but it has a positive charge. And that means it's not balanced in protons and electrons. So if we dissect that a bit further, we can determine, okay, it's always got 11 for protons, right? That's your atomic number or Z number. And then your neutrons would simply be 23 minus 11, which would be 12. Yeah, 12. Okay, 12 neutrons. Now electrons, we can't say we can't say they're even, right? Because we do have a positive charge. We would have to say that we lost an electron, right? We have one more proton versus the electrons, so we only have 10. Okay, because 11 minus 10 equals 1. That's a positive 1 charge, right? So what we're saying here in this notation where you see Na plus, technically it means plus 1, right? Plus 1. If it's 2, 3, and 4, you would see plus 1, plus 2, plus 3, and so on. But that's how you would determine, for instance, if you're given an ion, right, either a positive ion or a negative ion, how you would determine the number of protons, neutrons, and electrons in that setup. And this would basically finish out your atoms and notations, particularly the isotopes. Okay. And again, this is the conclusion of the series of the intro series to chemistry, whether you're high school, intro to college chemistry, or gen chem. And again, as you progress in the semester, things get a little bit tougher, especially if you're in college. But we'll end here, and then the next set of videos, I'm not sure how long it's going to take me to get through all these questions. I have 50 of them here, but we'll get through them as quickly as possible without going too fast. And I hope you enjoyed this video, and I hope you continue and do the review problems with me online. I think it's great practice, and we'll see you in the next video. Thanks.